Hey, thanks for coming by. Um, Working on my Android software, and now I have like these two different applications. One is kind of supposed to be a smoother, more refined app, and then what you have here, right here, is this CAN, I don't know, utility. CAN monitor is just the page you're on, right? There's commands. Um, and I wanted to show you some of the cool things that I kind of discovered here. And also, I wanted to make available. Some people have asked about code, and man, okay, so let me switch over. Will this switch over? Okay, yeah, let me bring this in. What we're looking at over here is my code, some of my code. And I just wanted to, people ask about my code, and I have like some weird feelings about it. Like, what I'm going to do is there's a link down, and I'm sharing like this file right here, this OBD2 device, which is really the core. It's really at the center of my code. So, yeah, for example, this right here, this is all the requests right now that I'm supporting, right? And this file actually has definitions of things. Like, here's all the errors that the dongle will get, or at least according to the data sheet that you can expect. A function to... Now, the thing is I'm just making this one file available, and what I'm looking at it here in Visual Studio, but you can get this, and I'm going to switch this other thing called, what is this? This is Notepad++, and this is a real common just basic text editor. But the really cool thing, and like everybody who uses software, anybody uses this. I mean, this is so useful. It actually will detect, right, that we're using C# language here. So the point is that you don't need any kind of special thing. It will sort of give you the syntax highlights. And of course, I've tried to indent and make it readable for you, for me, for anybody. I assume I'll die some point. Somebody else might. Isn't that narcissistic? Anyway, so okay. So these are, for example, all of the requests that I have so far. And the way that this works is, for example, and I'm just giving you the high level, right? This is not supposed to be a heavy technical thing, but basically I have these things called instruction sets. And here is an example of an instruction set to initialize the CAN. Actually, here's one to initialize the CAN monitor for use, right? So what do we have? We have a bunch of instructions to reset the device, turn the echo off, the memory, all these different things that we're sending to the device. It's a bunch of commands, and then like here I actually have to apply parameters to the commands, and then here you got to wait for the end, and then I have just this one lonely command here to start the monitor. Now each one of these commands though is actually defined in the file I'm making available to you. This other stuff, man, look, my entire project is tons of files. Look, there's so many files, and there's just too much stuff, man. Look at all these files. It's just too much stuff. I mean, it's megabytes of text files. Anyway, so I run these instruction sets, and the file that I'm making available to you is this, which has all of those instructions, any of those instructions I'm supporting right now. Let me go to where they are here in this. Where are they? Here they are. For example, let's say, right, to clear the DTCs. There's the command to clear the DTCs. Now, what you'll see is in some of these commands I have an extra byte because according to the spec, if you send ELM 327 the number of expected bytes, it'll save you in timeout. So if you repeatedly send the same command, what'll happen is on a very low level, I think it's 200 milliseconds, which is actually 20% of a second, which is actually pretty long. If you're doing like 10, that's like 2 seconds or something, right? Yeah, my mind. Anyway, so some of these will have, if you look at the specs, you'll be like, where's that one coming from? Where's another one here? This 3, right? the actual command is 0902. Here, get VIN. Okay, so get VIN is 0902, and it gets 3 commands back. Now, let's get back to reality. Let me just snap back to the software over here, right? Remember, that was, remember this in your head. The number is 0902. Oh, jeez. It's service mode 9, PID2 to get the VIN. Right, now remember, when I want to get the VIN in my instruction set, I'll just swear somewhere in here I'm getting the VIN. You know, I'll just, yeah, right here, like when I get a snapshot, I will just ask for the VIN. Right, so on a higher level in other parts of the programming, I'm not getting all involved in bits and bytes, and I'm just saying, hey, do this instruction set, you know, or maybe I'll just have this one command called, and then it will go in here and get all the guts. Now this code right here, for example, is the code that you would parse out the 3 bytes of data that come back. So this package right here has the code to send, the code to decode the code, some descriptor for it. Of course, it has you know, a nice other like encoded enumerator. You know, that's not text, right? This is just text. I could just change this to whatever, right? So this is actually just this one nice little, and I have what we do is we create a dictionary full of these. And I'm making this available. This file is going to be available, right? So when you look at it, actually, you'll be seeing it probably using Notepad++, which you can change the fonts or do whatever you want. So here's the exact, so I'm going to just switch over to this. I'm going to pretend like I don't have that special software, right? So we were just looking at the VIN. It's 902. I want to see if this is full of crap. Let's pretend like I'm watching, I'm not me, right? I don't know, maybe I'm not me. But I'm like, okay, let's see if this crap works. So this guy gives me a file. So let's say I got this text. It's just a text file. It's .cs. It's not .txt, but that's because it's a C# file. But it doesn't matter. It's still text. So you can come in here and look at any of these codes out here. 03. Get DTCs. We'll try both of these on the CAN commander. We won't even use my OBD2 software. So let's say we need an 03. So what are you saying? All I need to do is send an 03? Yeah. You send an 03 on a specific address into the CAN, and that is getting your DTCs. Get out of here, really? Well, I think so. All right, so let's switch back over here. So remember, it was 03. Let's go switch that back on, right? It's 03 to get the DTCs. Let's pretend we want to get the DTCs just using that CAN commander. 03 is get, all right. I've pounded that into my, I do that to myself so I can remember. Okay, so now I'm over here, and it's like Julia Childs, you know. Oh, we already have the thing cooked up and ready to go, and we're gonna just, you know what I'm saying? So I already had this set up ready to go with the 1 byte at 03. So let's send. Now remember, I'm sending. Technically, what's happening is I am on a CAN node, which is going to broadcast, but it's basically going to send its data out on 7DF, which is understood by the system as a specific address for scan tools, and I'm going to send out 1 byte of data, 03, and let's see what happens. Oh, you know that car is out in the driveway. Oh, it worked right away. That's pretty impressive. So actually, here is our DTCs, and you can go and look at the specs or whatever, but I can tell you it's 4303. You get right past that. That's like the response. 43 is the response. 03 is the PID. So it's like 4303 is the PID you sent me, and then the DTCs are P0193, P2107, and P2110. Now, actually, I have another problem, but I'll get to that later. But okay, so how do I know that those are the? Well, I actually have verified it, but like let's say I switch over to my so-called smoother app, right? So I'm going to read the DTCs, and if you remember those numbers, so this is live. This is hooked up to my car, and actually we see exactly these DTCs coming out. So now, this is really about this CAN commander. So the thing is that even if you don't have a scanner, you can actually send in an 03 and read the response. Okay, let's see. Read the response. Now, here's another thing that you might have noticed about my software. I don't hang on to that port. When you use my software, it opens the port only as long as it needs to. Other softwares will, because that's kind of gets a little crazy, opening and closing your connection to Bluetooth or Wi-Fi. A lot of developers will have a problem reopening or reusing that connection. You know what, I better be careful. At least at this point, that doesn't seem to be an issue. So you can run my app. Actually, you can run my application. You can open up another app, and then when you go to run my app again with another, like, Torque or something open, my app will be like, I can't access the device because the other thing's hogging it up the whole time it's open. That's why sometimes it'll connect, sometimes it won't connect. I thought it was going to have trouble. It will have trouble at some point. So let's try it again. Let's see. Out in the driveway. Wow, that's... Anyway, so, okay, so let's... what was the VIN? Anybody remember what that VIN was? So that was 0902. And, oh, by the way, notice how on the get DTCs, we really don't know how many bytes we're going to get back. So we don't specify a number of bytes to get back. Certain other ones, a lot of these PIDs, we know exactly, precisely. It's very specifically defined, so we can say precisely we're going to get 3 back. So for the VIN, that is the case. So 0902 is actually what we send in for the VIN. So let's switch back over and let's see. Do I have the Julia Childs thing? Oh, that's another thing. Do I have the... Oh, I don't... Oh, yes, I do. Okay, so 09, service mode 9, PID 2. Let's see what we get. This should be the VIN. And it is. You can just look at that and decode that or whatever you want. Boy, this is working pretty good today. What's up with that? Before I made the video, I was having all kinds of problems. I slightly moved it. There's metal under the table. Maybe that has something to do with it. But it'll just, if it doesn't connect, you just keep trying. All right. So, okay, so that's interesting. So what you have over here, right, I gave you the code, and makes it easy. You have, if you're really clever, you can take these and you can modify these slightly for Python or whatever kind of other language. This is C#. We're using specific type things. We got some dictionaries in here. Do we have any generics? I don't know. We might have some exotic. I don't think we have anything too crazy. Here's an example of where get DTCs, right? Now here's a function that stands by itself, and this might be something. This needs work, I think. This is something I just had to touch this week. So look, hey, take all this with a grain of salt, right? Remember, this is all an experiment. This function right here is highly suspect. I don't know if this is always going to work. Whenever my get DTCs don't work, it's this function that's failing. And usually somewhere in here. So I don't even know if this is right, man. I think this is wrong. I think this is whack. I think this code right here is a little... I'm making an assumption about freeze frame, but I think 2 might just simply be the number of DTCs that followed. So I suspect... So this is... Yeah, watch out. Watch out for this. Hey, and if you have any suggestions how to fix it or how to... Yeah, I would definitely take that. Right, it just builds a list. Anyway, you could study that for a while. Anyway, like for example, right, when I get DTCs, there's also get permanent DTCs and there's get pending DTCs. Now, I know, for example, there's no permanent, but I know there's pending, so let's get pending. Pending is 07, right? First 03 was get DTCs, but 07 is get pending. So let's, and we saw that, like the other thing, so let's, let me switch back, and we saw that the other thing, so what is pending? 07, so let's go back to the single, and we'll go 07. And do we get pending? See, now it's taken. Oh, it still came back. Nice. And we get the same 3. They're pending and confirmed. I don't know. That's what the car's reporting. Look right there. That's what the car's saying to us when we. Right. There's no scan. There's nothing between you and the car right here, or me and the car. It's just this CAN node, and this data is coming directly from the car. Anything else interesting here? I mean, I'm sorry, I'm looking over at the code. So, here's all the, like, any of these that start with AT, these are commands that are going to the device. They're really not going to the car, right? There's like echo off, right? That's just telling the chip, don't repeat my commands back to me. Buffer dump tells the chip, the ELM327 chip, give me what's in your buffer. And then all these weird kind of messages. These are setting protocols. And I'll do weird. There's inconsistencies like set protocol, right? The command is ATTP, but then I just have these like sort of macros that will just like, if I don't, because what I can do is I can say set protocol and then put something at runtime at the end of this, or I can just send a prepackaged version, right, with P1 here, or the protocol, TP for try protocol, SP for start protocol, search protocol, automatically or something. I don't know, something like that. Anyway, you can go look all this stuff up. But these are all commands and codes, and probably the most valuable stuff in here is this code, like this getting the PIDs code. I didn't even understand really what this was until it's like I'm so all right. Anyway, I won't go into that self-loathing stuff right now. The code gets kind of thick, man. Readiness object. That's a. Oh, look at this. Somebody's calling me. Jeez, get out of here. All right. Well. All right. All right. I don't have that on my screen, so I was worried you were just. People bother me all the time. Get out of here. All right, so let's see here. I don't want to hang up because then they'll know that I was aware that they called, right? So, all right, so readiness object is just a way of packaging up all kinds of stuff. Oh boy, I can't give you everything. It just will always lead to like, well, what's this and what's this and what's this? This will give you a lot of insight, but it won't give you everything, man. I don't know what asking for the so I'm trying to deal with people who ask questions like, hey, can you hook me up with code or whatever. All right, so I also wanted to show something that I just learned recently that I don't see anywhere, nobody makes it clear out there on the internet, and that is, how do you get the freeze frame PID DTC? How do you get what DTC is linked to the freeze frame data? And that's basically a 220 that you send in there. And I have to, I'm going to add this into my commands and do something with it. But basically, if I send that in, what I'll get back is it will report 2110 as the DTC that is linked to the freeze frame data. So now, okay, and also I added this hex feature so that we can figure out what, like, if you can have some kind of hex number like 7DF. Whoops. Actually, if you can enter either a regular number or, like I'm entering regular number, sorry, a regular number, and it will give you the hex value, and it'll give you actually the binary value. The max value you can have is 65,535, right? So, or you can enter hex values, and the max hex value is FFFF, right? So, as I mentioned occasionally and here and there, every hex digit is a nibble, which is half of a byte. So these four F's correspond to these four whatever cohorts of bits. This is 1 byte. This is two bytes. So this is 2 bytes of data. These are 2 bytes of data. And this is actually remarkably 2 bytes of data. I mean, what it is it's a way of expressing a value. What's at the heart is the value it's expressing, right? 65,535. But this just helps you to go back and forth. And what it'll do is we have a nice, I have an incrementer on there. So if you want to just kind of get a feel for how this increments, like if you watch that, basically what it is you just run out of symbols and you have to start using other columns. That's all it is. Over here, we just go from 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C, right? Let me go to 0, right? Just real quick. 9 to A, B, C This will run out immediately, needs a new column because there's only ones and zeros. This will go up to 9, and now it runs out of symbols and it needs a column. So it uses 2. This, we do this, it's almost ragtag. We just like, well, what are we going to use? Well, just throw letters. How many? I don't know. Stop at F. Well, actually, it's not arbitrary that we stop at F. But we use letters to get up to 15, and then we roll over, right? So basically, it's just how many symbols. The base of a counting system is all about how many symbols are you going to use to express one column. Here we got 10. Here we got, is it 10? Yes, 0 to 9. Here we have 10. Here we have 16. Here we have 2. That's it. And when you run out of symbols, you flow over to the column. So what you have a situation where you want to represent a number like, some number like 300, right? But you're going to use, what, 8, 9 columns of binary and only 3 of the other 2, right? The ideal thing about binary is, like, if this is a output of, just in your mind, imagine these are just like solder points on a chip, right? Hooked up to relays or something, I don't know. And then you can see how, like, when you're looking at code and it's like somebody sends some weird hex value to something to turn a relay on, it may be because they're trying to get one of these bits, they're trying to get one of these bits to go on or off, right? Just by changing a number. So anyway, this just is a page to help us just figure out what the hell's going on with hex and everything. Remember, everything is just one number. The numbers don't change. It's just how do we represent the number. All right. So over here, everything's hex, man, except for here, but you'll never get beyond 8, I don't think. What else? Set can ID was blowing up in the last version, I think. Will that work now? I'm hooked up to my car, so I probably don't want to do anything crazy. But yeah, I think that was blowing up before. See, now if I send in, none of this stuff's going to work now, right? None of this. If I go to the 03, so I have to be now. Even though 70F, that's because my memory was stored. My actual CAN ID that I'm operating is 444. So if I set my CAN ID back to 7DF. Right. Now if I just send, I should be, right, now I'm back on the scan tool address. Did you catch that? All right, I'm on address 7DF, right? I'm just going to change this to just some arbitrary whatever. Maybe I want to try something that I think will open a car window. I thought somewhere I saw somebody use this for unlocking their car, right? So I want to set my address to this, and then somebody told me, or I have a hunch. Uh-oh, see, now it's taking, see, sooner or later I knew that was going to have issue talking to the car out there. So now the idea of this node, this CAN node, is 580. So any command I send out is going to be on that node, which may or may not do something to the car. I mean, God knows what I might be doing to my car right now. But it is off of the scan address. So any like 03 is just not going to give me anything. It's just going to, I'm sending 03 to just 580, and it's the car's like, well, so what, So again, this thing changes just because it's part, because it was stored. When you do the memory store, right? If I store this memory store, it just stores. Did I lose something? Anyway, it just stores everything. So let me set back our address to 7DF, which also, if you just hit initialize, will do that. Right, if I set, let's say I set the address, right? If I initialize, if you're not sure what that, it'll set it to 7DF. Then of course back at 7DF, I'll get my scan tool diagnostics, everything that we were talking about and doing before works. Should work. Come on. And I think this was the VIN. Okay, so see, it's pretty agile. So this CAN commander page I think is pretty working okay. This CAN monitor over here, This is working much better than the last version, but it is still, I would not, you know, hang a rope from it with my life, you know what I'm saying? So now we got this weird concept of this mask and this filter stuff. So basically the simple thing is like, it isn't simple. It's crazy. It's weird. The mask, let's say I want to look for everything that starts with a 2, like 200, 211, 2, you know. What I'll do is make sure that third digit from the right, I know it's weird, man. Third digit from the right is the target. Everything else doesn't matter, and then there's got to be an F. It's got to be an F for the actual specific number. So if I'm looking for 2, I got to have an F in the third spot. The zeros mean anything. It means that ignore everything else, right? So what I'm saying is, if these were FF, it would say just look for 2FF, which I'm pretty sure is not out there. I don't think there's anything, right? So I want to look for everything that's 2, anything that starts with a 2. So what I do is this mask I set as 00, but I leave the F as because then it'll bring too much data in, or and that won't give you more data. It'll clog it up. It's like it'll bottleneck real quick. So it isn't like you'll get more. Although it tries to allow more. So when you change the mask or the filter you have to reinit. So it will reinitialize with these new address masks. And now let's see if I can, okay, so there it is. Now, all right, so this is fluctuating a little bit. And if I want to see what the crazy crap that's going on, I can switch over here. And this is not, you know, actually the flow is not good. It's not. If you get a buffer full, it will stop and it will restart it every second. But we shouldn't be getting a buffer full, so I don't know what's going on here, man. But it, you know, give it a shot. For example, I want to see everything that's got anyway, yeah. So let me just finish the thought, right? So anything that started with a 2, right, is what we did. And here's the thing, you got to make sure that there's exactly 8 characters in here, because with all these F's and stuff, you want these all F's unless you're the zeros or where you don't care. Only on the mask side. This side is sort of irrelevant if these are zeros and F's. It's either exactly what you're looking for or anything, right? F means exactly, zeros means anything. It's crazy. I know this is in the data sheet. If you go look at the ELM 327 data sheet, address mask, address filter, it's in there. This is exactly that. It's using the 29-bit capable, so that's why there's so many. Okay, so let's say I just wanted to see the 2 1s, right? The anything that started with a 2 1. What I would do over here is I would specify that over here. The filter is where you specify what you're looking for. And then instead of a 0, because it's saying ignore that, now I would put the F. Right? So now this is saying look for anything that starts with 2, 1, and anything. So let's see. Of course, we've got to initialize on that. And if the initialization was successful, it'll clear the list. We go listen, and now we should only see the 2 with the 1s. Right? I think there was a 3 in there. And of course, there's all kinds of crazy noise going on back here. I may just get rid of this, but I don't like to like block out. You know, I want everybody to have the liberty to see what the hell. There might be something useful there, and I'm not going to assume that there won't at this point, right? This is still just a tool. It's a hacker's thing, right? Okay, so let's see. Stop. And let's see, I saw a 3 in there. So let's say, all right, yeah, let's say a 3, right? It's still saying use exactly those. Let's initialize. I thought I saw a 2, 3. And then listen. Yeah, okay. And then let's say we want to just see all of the 2s again. So what I'm going to say is don't care about the middle digit. I'm going to stop this. I think I'm going to sneeze, actually. So if you hear me sneeze, I'm going to have to sneeze. Okay, let me. Oh man, thank you. Okay, so here we go, and we go listen, and we should get all the 2s again, right? So now let's say I only wanted to get everything that has a 2 on the how about everything that ends in a 1? Let's see what happens. I haven't tried this yet. So what would that be? Everything that ends in a 1 from the system. So this time now we want 1 as the end digit and everything else is not care. So 3. So we're going to say not care, care. Is there any? Okay. So now what we're saying is don't care about the 2, don't care about the 3, but we want exactly 1. Let's see if that works. Let's see what happens. Okay. So now what is implicit here is that in my entire system, 7s and down, I mean, it'll go from 0 to 7, I believe, this 3rd digit, this first or whatever, however. According to my CAN commander with my car sitting in the driveway off, there's nothing in the system that's reporting 1 as its last digit of its address. Is it possible that that's true? Maybe. It feels weird. I'm kind of feeling like there's millions of addresses, but maybe not. Maybe not. All right, so let's stop. Now, what happens if I just let loose on the whole system? I'm pretty sure it'll just crash. Not crash. The app should not crash. Let's see if it crashes, right? So let's init with don't care, which means like any address. This is an 11-bit system, so that means don't care. So let's see what we get. Okay, not a lot of data. Okay. What I believe is happening. Okay. Well, I don't know. So this is still a work. It's a work in progress, right? But I want to. Okay, that's interesting. So, I have this clear button, right? To just clear, like if you suspect, hey, data's not coming in any, because some of these just stay steady, right? Just clear, and then it'll refresh. So even if you have something that's just sort of steady, like, wait a minute, I don't know if that one's right, just hit clear. Same thing with this thing, but this is wacky. This is just raw, right? This is like there's no cleanup, there's no that's why I have it there, because it's just everything that's coming in. There's no parsing. This is a lot of these RX errors and things. I believe is because there's no acknowledges. I really don't know. It's like religion to me. It's like I gotta believe, right, or hope, and all that kind of stuff. Anyway, so here is where I'm sort of parsing it and cleaning it up and grabbing and testing and making sure that the number of bytes it specifies don't run out, making sure at the end of it doesn't say error, Actually, I don't think I do make sure it doesn't say error. So it's not as clean and perfect as I'd like it, but it's a lot better than it was, and it's there, man. It's a link down below, man. Have at it. Oh, and one last thing, I was crying in my last video about like my F-150 and I couldn't read codes. Gonna stop this. Let me come over to the commands. And we know now that if we just issue this 3 command on 7DF, that we should get our DTCs according to the OBD2 standard. Now we're hanging like, dude, what's going on? All right, when it hangs like this, what you can do is just switch to the other page, because that will automatically close it, and just go back to wherever you were. See, everything sort of, the message sort of may just get stuck, so let us see what's going on. Now, one thing I did not do is initialize. What do they say when you got a computer problem? Just restart everything. Right, so let's restart everything. Try to restart everything. Okay. Let's try to get our DTCs. Did I send a weird command into my car that won't allow it to work? This is interesting. I'm just going to keep recording this. Let's see, does this init? And can I listen? I can still hear stuff. I might have I just sent those commands. I did send commands into the system. So that dude who said I'm going to bring my truck to a real professional after or whatever, to a real what is going on here? 03. All right, let's try this. If a knit doesn't work, a knit again. Let's just a knit for the sake of a knitting. All right, anyway. So, jeez. I don't know what's going on. The truck is kind of out there. It should not leave us leaving in la la. Yeah. All right, so all right. I think I have communications issues, so let's try this again. Oh, I think there's an ideal spot on my desk where it works perfectly. All right, let's try to initialize. Actually, I think it's initialized. Initializing it is not doing anything to the software, really. It's doing it to the hardware. Geez, here we go. So once it's initted for like commands or monitor, and the initialization is slightly different. Oh, damn it, what did I do here? Now I can't reach the car. All right, let's try this. Come on. All right. Oh, look, see, I went init and the command was like buffered. What is the command? 43. All right, let's try to just send. See, I should have just taken. All right. Usually, if you just send commands right after another, it doesn't it seems to fall asleep after like a second. But like once you get connected, if you just keep talking to it, it's like there, it's with you. It's just like, oh, I ain't going anywhere. Anyway, so my point is that it took me 6 hours to get to was that you see that there's three DTCs in here. And my software, which is really the kind of important that I get this right, is reporting those 3 DTCs. Great, fine. But the thing is when I went out there with another scanner, with this Actron scanner, I paid $300 for it or whatever from Pep Boys, I think. I was getting these two codes. I think it was 21,000. It might have been 2,000, but it was like 21,000 was a subset of I think it was 21,000. They were both non-mill codes, but nevertheless, this scanner is like, yeah, you got these codes. Now, I really don't believe that the scanner was like just creating these like, oh, well, you have 2100, so I'm going to just deliver out. I don't believe that happens. That P1000, everybody who has a Ford knows that's the infamous P1000. It's like, okay, you're 6 months from now, your evap will reset. It's not a mill light. It's just saying not all of your monitor services are complete. I don't know where this data's come. I have no idea how to get that information. All these games and everything I'm playing here, I'm tooling around. I don't know how to get this information, where it's coming from. I think it has something to do with multiple ECUs on the CAN, but even though the CAN standard says that multiple ECUs may respond to this 03 command, which means that they should all show up here. All the DTCs, there, of course, it says emission-related DTCs. But nevertheless, I don't know at this point how to retrieve these commands. And right now I have a scanner that when I hook up to my truck, I get these commands from it. When I hook up my software, I get relevant commands. My software is useful enough. But it bothers me that I just don't know how to get those commands. Now, the freeze frame stuff, I'm kind of right on the tail of, right? I'm pretty much figuring that out. You saw how I showed that before, but these non-mill errors, I don't know how to get them. Okay, so hopefully the energy in this video wasn't kind of weird like the other one. The other one I was kind of, Because you know what it is? I discovered these errors. And they've been there since the beginning, and I'm horrified. I can't believe it. And I'm thinking, and I think this is a lesson, why we're alive on Earth, right, is really not to write software or to make money. It's really to do things or to make nice cars, just to develop ourselves. And one of the things is if you're like me, you're very harsh on yourself, right? Just like, you're trying to make things better, you're trying to make things perfect, right? And for my whole life, I've kind of viewed that as like, oh yeah, that's fine, that's a perfectly good, normal thing to do. But actually, no, it's not. Why? Not because of you, not because of it, but because you will take that energy and apply it to other people. And my girlfriend kind of is indicating that to me, and I have to listen, and I know, a little philosophy. The thing is, if you're very hard on yourself and you're like, well, I'm hard on myself, but it makes me better, it does not. It doesn't make you a better person to be really hard on yourself, because you will subconsciously take that same sort of criteria, that same standard, that even if you don't say the things, you may curse at yourself and call yourself names, and you may not do that to other people, but you will take the same energy behind it and you put it on other people that you have expectations for. Maybe they're working for you, maybe they're in your family, and you're having. So this is like something I've learned very recently, like through this software and through people, is that you really can't be too hard on yourself, because if you're a decent person, you're going to you can't compartmentalize it to just yourself, because you're an equal opportunity person and you will bring that energy. Okay, very good. You got the point though, right? You get what I'm saying? All right, very good. So I hope you don't mind a little bit of philosophy at the end there. I'm just sharing. It's like I'm sharing what I've learned, right, about stuff. And the software, to me, I'm writing software to do life. I'm not doing life to write software. All right, I'm not sure if that makes sense, because that just came out without thinking. All right, so thanks a lot for coming by. Appreciate you watching. This software here, it's available down there. Try some of this stuff out. Oh yeah, the code link. So you got them codes in there. Those codes in there, I should say. Have at it, man. And have a great day. Where's the